Hello everyone, this is Mahmoud Islam Nayon, I12008021. I am a student of Department of CSC from University. Today I am going to present a topic, self-supervised learning, teaching machines without levels. Without any further ado, let's discuss about the topic and its basics. So, first of all, what is self-supervised learning? Self-supervised learning is a method where model generates their own levels from input data and learn without human annotated levels. What is the basic difference between supervised learning and self-supervised learning? In supervised learning, the leveling of data is needed so that the machine can learn from that level. But in self-supervised learning, there is no need for level. The machine learns on its own. We can say that predicting missing parts of a sentence or an images as an example of self-supervised learning. Why self-supervised learning matters? As we know, supervised learning needs levels for data, but self-supervised learning doesn't. So, supervised learning has its own problem, like leveling the data is expensive and time consuming, hard to scale across domains. And SSL solved these problems because there is no need for levels and also reduce dependency on human experts. How self-supervised learning works? We can divide the self-supervised learning works in two parts. One is pretext task and other is downstream task. In pretext task, it creates an artificial task that forces the model to learn meaningful features, and in downstream task, fine-tuning the model for actual real-world tasks like classification, detection, etc. Let's talk about some example of pretext task. In NLP, masked language modeling, fill missing words, example BERT, next sentence prediction. In computer vision, image in painting, predicting missing parts of an image, rotation predicting, guessing the image rotation, contrastive learning, find similar or dissimilar images. There are some models that are famous for self-supervised learning. They are BERT, GPT, SimCLR, MOCO, BYOL, and Dino. We already discussed about, we already talked about BERT, and we know that by this it learns languages understanding by masking and predicting words. GPT predicts next tokens. SimCLR contrastive learning for images. MOCO better image feature learning. BYOL bootstrap your own latent learns without negative samples. Dino learns visual representation without labels. Let's talk about the architecture, and it look at the image. It's given the basics of the basic level of architecture but when an example when a sentence given to BERT, like let's say the cat dash on the mat, we expect the BERT to predict the word set. By doing this on billions of sentences, the machine learns about grammar, meaningful structure without supervision, and finally it can predict the same word, and which is very good because we don't need any human supervision. There are some applications of self-supervised learning like language understanding, medical image analysis, autonomous driving, robotics, and recommendation systems. Of course, self-learning self-supervised learning has its own challenges. Creating good pretext task is an hard work because when the task is good, then it is very easy for the machine to predict and learn. But and sometimes it becomes computationally expensive. There are some feature in this part because self-supervised learning reduce the dependency on humans, so it is the foundation of modern AI, and we hope to see multimodal SSL like text, image, and audio together. In conclusion, we can say that self-supervised learning is the future of scalable AI. There is no need for levels, and today's advanced models are powered by SSL. Thank you everyone for listening till now. We will discuss more about this topic in our next video. Till then, goodbye. Assalamu alaikum.